Hi, everyone. My name's Eric. I'm the co-executive director at Cal Poly.
And I'm Ethan. I'm the director of tech here at Cal Poly.
And today we will be showing everyone an intro to Git. And our presentation is called Getting Started in Intro to Git. And yeah, we will be taking you through the basics of Git, as well as trying to show maybe some stuff that people don't know. So we'll go ahead and get started. Cool. So before we start, I'm just going to talk about an overview of our presentation. So we'll start off with installing Git and creating a GitHub account if you don't have those already. We'll talk about what is Git, and then we'll delve into some more core Git concepts like commits, repos, branches. We'll talk about collaborating on teams and what that kind of looks like, what's used, the difference between Git and GitHub, as well as some general Git etiquette, and going backwards in your code with Git resets. And we will end our presentation with a demo. And to start off, this is just a quick check if you have Git, but you can just in your terminal run git -- version just to check if you have it. And if you don't have a Git version showing up, you can install Git for your operating system at one of the links shown here. So definitely do that on your own time. And then also create a GitHub account. It's where you store all your Git repositories online. There's other places like GitLab, but in my opinion, GitHub is where it's at. And so, yeah. And to start off, so what is Git? Git was created in 2005 by Linus Torvalds, the creator of Linux. And he was using it as a tool for Linux kernel development. Git is a distributed version control tool. And so what does that mean? And what is version control history? It's a system that keeps track of changes to a file or a directory of files over time. So you can refer to specific versions later. It's great for collaborating on large development teams where you're working on a large project. It allows you to track down what changes were made and when. And also it allows you to revert back to a previous working state of code if you, say, needed to go back. And Git is a local tool. You don't need internet access to use Git. It can just work on your local machine. And you can connect to, say, a remote server with internet access by doing Git push and a Git pull. Also, what is Git modeled after? It's a directed acyclic graph, and where the commits are nodes, and each commit points backwards in time to a previous commit. That way it can reference its parent and therefore its history. And so, yeah.
Yeah, awesome. So now we're going to talk a bit about like what Git actually is. So Git is really built off of things called snapshots. And just like a picture, these kind of track like what's going on. You take a picture, that's how things are. So it records the state of things at a certain time. And you're the photographer in this analogy. So you get to decide what to take a picture of and kind of when. So actually taking a snapshot is called making a commit or committing. And it does a little more than just take a snapshot. So it does do the snapshot, but it also tracks who made it. It references the previous commit. That's kind of how we get that acyclic directed graph. And it also comes up with a hash name. So a collection of commits is what makes up a repository. It's basically the series of commits from the very start all the way to wherever the project is at a given time. And kind of like a photo album, or this would kind of be like a photo album if commits are the photos. You can look through it. Pretty cool stuff. So actually getting ready for commitment or committing files, first you have to stage them. And this is done through git add, which takes files from your working directory and puts them into the stage directory. And that's basically telling Git like, hey, I'm about to commit these. So once you've staged all your files, then you actually commit them and it's history from there.
I'm down to surf this weekend.
So we also have branches, and all commits kind of live on a branch. At the very start, this is just the main branch, but like a tree, you can start at the trunk and branch off of it. And in that tree analogy, it's kind of like the commits would be leaves. So the structure of Git, it's really designed to make branching super easy. It's something we'll want to take advantage of, and we'll talk about like how we can do this a bit later. And in this picture, we start on the main branch, and like I would decide, hey, I want this super cool feature. I'd branch off. My work's in blue. Someone commits to the main branch. That happens. The orange person's like, oh shoot, here's a bug fix. Let me branch off, fix that. And all of that eventually gets merged together. So checking out is really about jumping around your code. This can be between branches as well as the history of your actual repository. So switching branches is something super useful for multitaskers. Like if you want to work on a feature, this feature, you do it in this branch, another one up here. It lets you jump around without mixing all those changes together. And you can also jump back in time, which gets super useful if all of a sudden you have a bug. You can't really figure out why, but you could try and find it by jumping around through your code. And in both cases, checking out a commit or another branch actually replaces the code in your working directory, letting you see like the repo at that state in time. So with branching, you may have noticed like, oh, tree branches, they don't really come back together. That's where that analogy kind of breaks down, but we're able to merge it with Git. So it's putting our code back together. This is done by hopping onto the branch you want to merge into and then saying git merge that branch. And some of the times it'll work perfectly fine, no conflicts. But other times you might have like tweaked code in the same spot and Git's like, oh shoot, something happened, we got to fix this. But Git actually doesn't know like how to fix it all the time. So it says, hey, you're the developer here, you really know what's up, and it gives you kind of something looking like the thing on the right side. You can see like there's head, green text, an equals line, to do, and master line. So that's kind of saying, hey, this code on top is in the thing you're trying to merge from. The code on bottom was already here. It's up to you to figure out how to fix that. And you would delete the lines you don't want, keep the ones you do. And that's basically how to resolve a merge conflict. So Git's super powerful on its own, but it's also really useful for collaboration. So Git versus GitHub, it's like these sound super similar, but you can kind of think of it like porn and Pornhub. Like you have the content, but it's not really the same. One hosts the, like repos, I guess. So yeah, Git's the actual control tool. GitHub hosts it all. GitHub's actually huge too. Over 100 million repositories, just all out there. And it really adds to Git. Lots of features, as you can see, like issues, pull requests, even GitHub Actions, which is like free computing, project documentation, and a lot more. So with working with a remote server, you'll have to keep up to date with the current code. And that's kind of up to us to do. And we'll do that by pushing and pulling to GitHub. So pushing sends your local commits and changes up to the cloud, and GitHub deals with that. And when other people make pushes, you might have to pull it to keep your code base up to date, and you would do that with a git pull. So working on a team, this is like really why we learn Git. It's really nice as is, but there's certain etiquette we want to follow, just so all our code stays clean, workflows are nice, and this kind of comes into play with cloning, commits, and branches. So to start working on a project, you have to actually clone all the entire repository from the remote server. This could be done directly from the repo, which would just make an exact copy of everything on the server, or you could fork it, which what that does is it makes a virtual copy of the repo, and then you clone your virtual or remote copy. And that's definitely the most common practice for large open source projects, but directly cloning from a single repo usually works pretty well when working on small teams. And regardless of like forking or not, you'll still have to clone from a remote server onto your local machine. So commit etiquette. Commits are really how we track progress of the project. So we want these commit messages to just be super descriptive, make a lot of sense. And we can do that by using descriptive messages, explaining what applying the commit does. So like this commit would add the ability for mobile login. Like that'd be a commit message example. We also want to keep our commits really small or just focused on a certain feature. So we wouldn't want to mix like that mobile login with typo changes, with CSS fixes. Like, no, this should all be separate. That way someone else can easily see like this did that, that did this, and so on. And that also allows for having those small commits allows for quicker development. Since you're making commits, you're pushing them up. And when someone is pulling those commits down, there's just less chance for a merge conflict to occur. And then with branches, we really use these just because they're super easy to create. So we want to take advantage of them. The main purpose is to keep the main branch clean from clutter. We don't want a ton of tiny commits littering our main branch. So we would create a branch if we wanted to say like add a feature or experiment with like, hey, what if we did something this way? Or even things like fixing a bug. I mean, Git makes it easy enough to just make a branch. So usually we'll do it for like really whatever kind of change we want to make. And naming conventions for the branch kind of vary between teams. There's not like a definite answer to how to do this, but there's an example on the slides. Like you could say what type of branch it is and then what it's for. And that just kind of keeps everything pretty organized.
Yeah, so I just want to touch on where code kind of lives when you're using Git. Ethan kind of talked about these areas earlier, but I just wanted to talk about them more in depth because they are pretty important. But as far as Git is concerned, code can only live in three places. That is your working directory, the staging area, and history. So the working directory, that's just basically where your code base is, and that's where the .git directory will be located. The staging area, you can kind of think about this as your commit shopping cart. Like why do we need, I guess, an intermediary step between working directory and history? It's because, we want to actually see like what commits we want to theoretically like buy and, purchase, to use that analogy. History is where, the commits actually live, and that's where commits are made. And whenever you're doing, your typical workflow of git add and git commit, that's going kind of forward, right? You do a git add, git commit, git push. And that's what developers are used to that have, kind of just a basic knowledge of Git. The going backwards is where it gets a little bit tricky because going from history, say like you committed something, and going back to, putting that in the staging area or putting that back into your working directory, that can be pretty, I guess, complicated. And that's where resets come in. So git reset, there's three different ways you can do it. By default, if you just did git reset file name, you didn't specify a flag. And the flags are just --soft, --mixed, or --hard. If you don't specify one, by default, it'll use --mixed. And what that will do, it will undo a commit from history and put all your changes in the working directory. And so the different ones, so doing a git reset dash dash soft, say you undo a commit, and then those changes from that commit are already staged in your staging area. And this will all make sense when I go into the demo, because I'll be showing kind of this kind of stuff. Git reset dash dash hard, that's probably the most extreme reset that you can do, because it'll undo the commit, but it'll actually just trash those changes. So you don't actually get the changes or any of the work that you did in that commit. It'll just go into the trash. Yeah, and so this next slide is going to be a joke courtesy of Sarah Ford. If any of you had the chance of having her for like 307, but she had this analogy of git reset dash dash hard 2020. Wouldn't it be great if we could do this with this year and just, trash all the changes made thus far and go back to January 1st, 2020? That's a bad joke.